Greetings and salam sejahtera. This is an assignment presentation for MAT455 and this presentation is prepared for our lecturer Dr. Muhammad HAKIM bin JAMIL. So first of all, I would like to introduce myself. My name is VALENTINIE NOTTELMARC and my matrix number is 2022-9496883. I'm from the group of CEEE 2233D. Okay, so here I would like to present the first task. Okay, let's move to the first task. The first task is about the double integral. Okay, here given a region, and we need to plot this region inside the GeoGebra mathematical application. Okay, after we insert first here inside the GeoGebra, for the first equation, which is the a function is, I put the range for the x range. So as we can see here inside the GeoGebra, it will display like this. This curve is the range for 4 minus y squared is lesser than x lesser than 4. Okay, so next we will plot the next range for y range. Okay, so we will get this yellow region. Okay, so here this is where the region that we will need to calculate for the area. So next we will evaluate the given integral. Okay, it asks us to evaluate the given integral, which is this integral. Okay, since we will first of all we will integrate respect to dx, so we will use the type 2 method, which is we will see from the left hand side. We will meet the 4 minus y squared line. After that we will meet the x equal to 4 line. So this is our region and we will need to evaluate this integral. After we integrate, like we are using the basic integration, and here I use the integration by substitution method, where I will substitute the u. I will let u equal to y squared, because here we have exponent power of y squared. So I will let the u equal to y squared, and then I differentiate it, it will equal to 2y, and then I will let dy equal to du over 2y, so I can substitute it inside this equation. So lastly we will get this equation, which is 3 exponent power of 4 plus 1 over 2. So this answer must be the same if we reverse the order for the question 1c. Okay, we look at it. Okay, just now we are looking using the type 2 method, which is from the left hand side. Okay, and then this question, it asks us to reverse the order. So if we reverse the order, we need to change the place where we look the graph. So we are using the type 1. We will use dy first. We will integrate respect to dy first, because we are using the type 1. We will look from downwards to upwards. Okay, so for the range, we will get first, what we'll get is square root 4 minus x, which is this line. And after that, it will get into the y equal to 2 lines. So here the range is from square root 4 minus x until 2. Okay, and then the range for x is from 0 until 4. So that's why here is 0 until 4. So after we integrate it using the basic integration, and then here I will using the integration by parts, because here we have two variables that we cannot integrate directly, and I will use the integration by parts. So using this method, I will get this, and then integrate again, and then I will get the last answer will be the same with the 1b. As we can see here, yeah, we have the same answer. So 3 exponent power of 4 plus 1 over 2. Okay, so let's move to the second task, which is about the triple integration. The first question, it asks us to plot this bounded region into the GeoGebra application from each projection, which is from x-axis, y-axis, and z-axis. So for the for the 2a question is from the projection of x-axis. We'll see this type of bounded region from the GeoGebra application. Okay, if we are from the y-axis as the height, we will get this kind of shape. We will see this is the bounded region that we want to calculate after this. So from this y-axis will become the height. After that, for the C to C, will the z-axis will become the height, and we will see this part of bounded region. Okay, so next we will need to find the volume of from each projection if we are using the x-axis as our height. Okay, so here if our x-axis as our height, we will map first the line for the height is y squared, which is the curve. Okay, this line is this curve is for the y squared, and then we will meet the y 1 minus z, which is this plane. We will meet this plane because we are using the x-axis as our height. After that, for the the base is from z-axis and y-axis. Okay, firstly we will make the 0 from this 0 until the 1 minus y squared, which is this plane. And then the range is from -1 to 1. That's why we have this range. And then we will integrate it, and then we'll have the answer. The volume answer is 8/15. This this volume must be the same. This answer must be the same for all projection, because we use the same bounded region, we use the same shape. The volume must be the same for all these questions. Okay, so for the next, we are using the y-axis as our projection, as the height of our bounded region. Okay, so here, if we look at this axis, y and x axis, I take these two axes. So we will first make the negative square root x for our lower limit, and for our upper limit is we will get the positive square root x, because this is the y squared curve we have here. And then after that, for our base, we will get this base. So we will get from 0 until 1 minus z, 1 minus z, yeah, here 1 minus z. This is our plane. And then for our range, we will get from 0 until 1. Okay, so that is for the y-axis, and we integrate it. So here I use the integration by substitution. I let u equal to 1 minus z, because here we cannot integrate. It is really hard to integrate this power of 3/2. So I will use the let u, which is the integration by substitution. Okay, so we can, as we can see here, for the second question, for the 2b, we also get the same volume as the 2a. Okay, for the last one is from the z-axis. Okay, as we can see here, this is the height when we look at the z-axis as our projection. Okay, so firstly we will make the line of 0, and then until if we go up again, upwards again, we will find the curve, this curve, which is for the 1 minus x plane. So this is our range. We will get from 0 until 1 minus x. Okay, for our base, this is our base. Y and x axis as our base. And then the range is from y squared, because we get this curve first until here, which is 1 for our intersection at the x axis. Okay, so for our range is from -1 here, intersect at y, and until 1, intersect at y also. So this is the range for the z axis. Okay, so if we integrate it using the basic integration, and we also can see here we will get the same volume for the z axis. So this means if we look from left, right, or from bottom, from upwards, we will get the same volume for each types if we change our method when we see the graph itself. Okay, so that's all from me. I think I have reached the end of my presentation. So thank you.